Hello friends, welcome to Science Stupidity. And anything could become a black hole if you were to compress it into a small enough space. A tiny amount of space that were you to collapse the entire mass of the object into. Its density would be so great that its gravitational pull would be so great that not even light could escape from it. You would have a black hole. If you were to compress the entire Earth down to the size of a peanut, it will become a black hole. But fortunately for us, there is no known way to compress Earth in that fashion. So the first question that comes in our mind, what is black hole? A black hole is the region of space-time where gravity is so strong that nothing, no particles or even electromagnetic radiation such as light can escape from it. And that's why it becomes difficult to see a black hole. But why? To see an object, it is necessary to have a reflected light ray from the object, or the object itself should emit light rays to enter into our eyes. And this is how we see an object. Here we require light rays coming from the object to see. We see stars because light rays emitted from them directly enters our eye, but stars much more massive than our own sun when runs out of fuel and can no longer keep itself hot enough, it collapses to a single infinitesimally small point known as a singularity. When you go towards a black hole, there will be a point in space where once crossed there is no going back. It is at that point that light can no longer escape, and the only thing which is visible is complete darkness. If it is so, then how do we detect the presence of a black hole? Seeing object that does not reflect light is tricky business. That's why astronomers don't exactly see black holes directly. Researchers have known about black holes ever since their existence was predicted by theories such as Einstein's general relativity. Knowing that they are invisible, however, scientists have devised clever ways to detect the presence of black holes indirectly. One method has been to watch the demise of objects falling into these cosmic graves. If materials actually falls into a black hole, it gets shredded apart and it heats up. As it heats up, it starts emitting radiation like X-rays, and these rays can be observed through advanced telescopes. The superior sensitivity of these telescopes gives us enough information which, if satisfies the specific predictions of Einstein's theory, confirms the presence of black holes. Another technique used for identifying black holes is looking at how objects neighboring one behave. So actually detecting the presence of black holes is looking for objects near the black hole that you can actually see, that move much faster than you would mainly have expected on the basis of the assumption that there would not be a black hole. The motions of the stars of these binary systems are detectable by ground-based as well as space-based telescopes. Thanks for watching.